In this video, we're going to start to work with inverse functions. So from our previous introduction video, we know that an inverse function just undoes a function. And so let's talk about this function right here. We have this parabola, and we're asked to plot the inverse. So what we're given is points on that parabola. So we can come up with points on the parabola by just plugging in different x values. We know the vertex is going to be at -2, -1, like this. So it makes sense to pick two numbers that are to the left of the vertex and two numbers that are to the right of the vertex. And that's what we did here. So we plugged in these numbers into our function, and this is what our output was. This is what our y values are. So an easy way to graph an inverse is to take the points of our original function and flip them, because we know that in an inverse, our inputs now are our outputs and our outputs now are our inputs. What that means is instead of our function, we input -4, we get 7. Our inverse would be that we're inputting 7 and we're getting -4. So in our inverse then, a point would be input of 7, output of -4. How about for this point here? In our original function, we're inputting -3 and the output's 1. For the inverse, the input will be 1 and the output would be -3, and vice versa. So all we're going to do is we're just going to flip these points, and that's how we get the inverse function. So now that we have those points flipped, we can sketch them. So 7, -4 won't quite fit on the graph that we're given, and neither will 7, 0, but these 3 points will. So that's what we sketched here. So I'm going to connect them all. And here is what we've got. So this is a sketch of our original function, f at x, and this is our inverse function. So I'm going to put a -1 here, f inverse of x. So when we see a parabola sideways, that function is just called the inverse of a parabola. So this is the inverse of a parabola. So graphically, there's a pattern that emerges, which is that these two are reflections of each other in the line y equals x. The line y equals x is made up of these points here. Y equals x, if we were to make a quick t-table, our points would be 0, 0, 1, 1, 2, 2, 3, 3, 3, etc. So it's going to look like this. So let's connect it. And we can see that these two parabolas and its inverse are perfect reflections of each other in this line. So let's go over what we know so far about inverses. First is that the inverse of a function is denoted by f -1x. This is not a power, an exponent, okay? This just means inverse of f at x. A function is a mapping. If a function is a mapping of x to y, its inverse would be a mapping of y to x, which we found here. Here's x to y, so the inverse would be y to x. Graphically, a relation and its function are reflections of each other in the line y equals x. We know that. And finally, the domain of the original function is the range of the inverse and vice versa. So we can see in this example here is the domain of the original. -4, -3, -2, -1, 0. Those are just some elements of the domain. And you can see that it now becomes the range, the y values of the inverse. And that goes the same for the range of the original too. So here are elements of the range of the original, and now they are the x values or the domain of the inverse. Now instead of working with graph, let's work with the equation. So we're asked to find the inverse equation of this function, and then determine the domain and range of each of the original and the new inverse function. So how do we come up with the equation of the inverse? So the first step that I like to do is rewrite f at x as y, because it's easier to work with y. So we know that an inverse really just means that we're swapping these x and y values. Okay, our x values are now going to become our y, and our y values are now going to become our x. Another way to think about it is that we want to know what we'd have to do to y to get our x values back. So another way to think about it is that we're really going to be isolating for x here. So you have two choices. You could start isolating for x, or you could immediately interchange x and y right away. So that's another option that you could do. Interchange x and y right away. So I'm going to switch x and y. And now I'm just going to isolate for our y value. Alternatively, you can just leave x and y where they are and just isolate for x. But let's isolate. Now that we swap them, we're going to isolate for this variable here. So let's get y by itself. So I'm going to move the 3 over. I'm going to divide by -4 on both sides. This guy will go away. And let's just simplify this. So I'm going to divide each element by -4 here. And then let's just simplify. We don't want to leave a negative at the bottom of a fraction, so I'm going to rewrite this as -1/4x. These are equivalent. Just because I know this is going to be a line, so I'm going to sort of write it in mx plus b, y equals mx plus b form, so that we can easily sketch it. So -1/4 is equivalent to 1/-4. -3 divided by -4, we know that that can just become +3/4. And here is our inverse function. So to denote the inverse function, we're going to change y to f inverse of x is equal to -1/4x plus 3/4. And there is our inverse function. Now, as for the domain and range of this, we have the option of using this graph to the right if we need to. However, we know that these are both linear relations, and we know what the domain and range of linear relations are. We know that it's just going to be x is an element of R and y is an element of R. Of course, there is one type of linear relation that wouldn't have that domain and range, and that would be a completely horizontal line or a completely vertical line. But we can just take a look at this. We can see the slopes are not undefined or 0. So we know that in this case, that both of their domain and range are going to be x is an element of R. So here is our domain and range. So one more time, our original function is f of x. It's just a linear function with a y-intercept of 3 and a slope of -4. That's going to hit every single x value and every single y value. And here is our inverse function. It's going to have a slope of -1/4 and a y-intercept of 0.75, and it will also have a domain and range of all numbers. Let's try one more example. So here we're given a parabola. We can tell that the vertex of this parabola is going to be -1 and +2. And we're asked to come up with the inverse equation and then what the domain and range of this guy is and the inverse. So let's first start off by coming up with the inverse equation. So I'm just going to replace f of x with y. Those are the same thing. And then I know that for an inverse, we're actually going to isolate for x instead. And since x is going to be our new output and y is going to be our new input, I'm going to swap out the letters x and y. So I'm going to put, instead of x, I'm going to put y. And now I'm going to isolate for y. So the first thing I have to do is I got to move this 2 over. So it's going to be x minus 2 equals -y plus 1 all squared. Before I can square root both sides, because if I were to square root it here, I'd have to square root -1, and I don't want to do that. So I'm going to first get rid of that -1 by dividing by -1 on both sides. So we're dividing by -1 on both sides, and we're left with, on the left side, I can break up that -1 like we did before. That equals y plus 1 all squared. And now I can get rid of that squared by square rooting both sides. Okay, super important here is remember that when you're square rooting, there are two solutions, okay? If you forget what we talked about previously, if you were given this question here, and we're saying what can x be, there are two solutions here. X could be 3, Or x could be -3 because both of those numbers squared will equal 9. So when we're solving an equation like this and we're square rooting, we have to put a plus or minus in front so that it will give us the answer of plus or minus 3. So we have to put a plus or minus right here. Let's simplify what's underneath the square root. So what's underneath the square root? X divided by -1 is just going to be -x, and then -2 divided by -1 is going to be +2. And then we have y plus 1. Our last step is we're going to move that plus 1 over. So we've got plus or minus square root of -x plus 2 minus 1 is equal to y. And there is our final equation. So we can rewrite it as an inverse. So f inverse of x is just going to be plus or minus the square root of -x plus 2 all minus 1. There's our final inverse equation. So that's just a bit of algebra work. Now we're asked to come up with the domain and range of the original and its inverse. So this is where it would make sense to maybe make a sketch. So what do we know about this original? So what do we know about this original here? Let's just make a little t-table. What do we know about the original? What do we know about the inverse that will help us to sketch? Well, the original is a parabola, we know that, and it's in vertex form, so we know that the vertex is going to be -1, +2. So the vertex is going to be -1, +2. Which means we know a point on the inverse. If this point exists on the original function, then what point must exist on the inverse? 2, -1 must be on the inverse. This might not feel like enough to graph it. So another easy point that we can find is the y-intercept. And we know we can always find the y-intercept by just subbing in x is equal to 0. So if we were to throw in x is equal to 0 into this equation, we would get a y value of 1. So the y-intercept would be, a y value of 1. So the y-intercept would be 0 and 1. So if we know the y-intercept on this original function, then we know another point on our inverse function. It would be 1, 0. So let's use these hints here to try to sketch our original function, and then we should be able to get a good idea of what the inverse looks like, and then we can come up with the domain and range. So let's start with the original function. So we know that the original function has a vertex of -1, +2, and it has a y intercept of 0, 1. This makes sense because this parabola is supposed to be opening down. So it must look something like this. Let's fill in the information that we know about the inverse function. Before we do that, it might be helpful to also draw in the line y equals x. So really quickly I'm going to plot those points of y equals x, and then we'll connect them together just because visually it's easier to graph the inverse if we have this line here, because we know that the two functions are going to, or the two relations are going to be reflections of each other in this line. Okay, so now let's try sketching out our f inverse. So we know that one point on the inverse is 2, -1. So we're going to sketch that first, 2, -1. There's the point. And we know that we have another point of 1, 0, 1, 0. So now how to connect the dots. So we just got to think about this really. So we know that this is the vertex, this guy here, which means that this is like its vertex. This, we know that this is going to be a parabola turned on its side. So we can consider this like the vertex, which means this is our starting point, and there must be an arm that comes out this way, and there must be an arm that comes out down that way. So let's sketch that. So it must look something like this. And we can see that if we were to look at it along this line, these are reflections of each other. So now we're ready to come up with the domain and range of each of these. So this was our inverse, the blue one. Here is our original. Doing a sketch can usually help us to come up with the domain and range. So now with this sketch, we're trying to figure out the domain of the red guy here. So we can see that this is just a parabola. So the domain is going to be x as an element of all real numbers. And the range, taking a look at this red guy, is y can be anything less than 2. Y can be anything less than 2. So we're going to rewrite this as y is an element of R such that y is less than or equal to 2. So now for the inverse function, our blue guy here, we can see that x now has a restriction. X has to be less than or equal to 2. So I'm going to rewrite this as x is an element of all real numbers such that x has to be less than or equal to 2. And then our y values, y can actually be anything for this sideways parabola. Y can be anything positive, it can be anything negative. So we're going to say that y is an element of R. There was a shortcut to this. Take a look at the connection between the original functions domain and range and the inverse functions. Look at this. The domain of the original is now the range of the inverse, and the range of the original is now the domain of the inverse. And so if we have the domain and range of the original function, it makes sense that since we're swapping x and y, our domain and range is going to swap as well. That's literally the definition of an inverse. Our inputs now become our outputs become our inputs. And so that would have been a faster way.